I'm Paul Dufresne, founder and CEO of Viridia Energia, and I'd like to talk to you today about the liquid metal energy storage system.
The major sources of renewable energy all share the same Achilles heel: wind, solar, hydro. They are often available when they are not needed and not available when they are needed. This has turned out to be the number one difficulty with renewable energy. If excess generating capacity could be stored until it is needed later, the Achilles heel could be fixed. But the experts in the renewable energy field, including Bill Gates, know that the current methods of storing electricity are not up to the job. Some type of innovative approach is needed. The need for grid energy storage is well recognized, and growth in this sector is widely predicted, although agreement on just what technology will be used is lacking. What attributes would a really good grid energy storage system possess? More than anything, it must be inexpensive. Other attributes are part of being inexpensive. The storage should have a high energy density, and it should be possible to store energy indefinitely, meaning that the storage medium must be stable. One other consideration: the storage system should be easy on the environment. Future generations should not be digging up the legacy of our methods as long-lasting pollutants, as we are now doing with buried hydrocarbon fuels. The answer to all of these needs? The liquid metal energy storage system. In this system, two liquid fuels are combined in an electrochemical cell to produce DC electricity with an open circuit voltage of approximately 3.5 volts. The two fuels are elemental chlorine and a eutectic metal alloy. Chlorine is a gas under ambient conditions, but becomes a liquid at ambient temperatures at between 7 and 8 atmospheres, or about the same pressures used for LP gas, otherwise known as propane gas. The metal alloy has a melting temperature of minus 12.6 degrees Celsius and is a mixture of two metals, sodium and potassium. When these fuels react with each other to produce electricity, the product of the reaction is a mixture of sodium chloride and potassium chloride. Sodium chloride is also known as table salt. Potassium chloride is used as a glaze on specialty bread, so they're both edible. Both of these are very abundant on Earth's surface, and in fact are among the 6 most plentiful ions that are dissolved in seawater. So this system starts out with a mixture of sodium and potassium salts, two of the most abundant and inexpensive chemicals. These are run through an electrochemical device that consumes DC electricity at approximately 3.7 volts to render the mixture of salts into two fuels. Chemically speaking, the process used is quite similar to electroplating. The two liquid fuels can then be stored as bulk chemicals in large storage tanks. How much can be stored? The only limit is the number of tanks you want to build. In other words, there really is no practical limit. To use the stored electricity, the two fuels are fed into a different electrochemical device, producing DC electricity and regenerating the mixture of salts. This technology is known as a fuel cell, although it is very different than the many forms of hydrogen-oxygen fuel cells familiar to most people. In this way, the mass used as fuel can be endlessly cycled through the reaction. The result of all this is very inexpensive energy storage. Lithium-ion batteries are said to have a cost per kilowatt hour of $250 to $350. By the same measure, the liquid metal system has a cost of 18 cents per kilowatt hour. This is a price reduction on the order of 1,000 to 1. Such a reduction holds the promise of making renewable energy the source of all of society's electrical requirements. Benchtop lab tests have shown that the chemistry works, that electrical energy can be produced from this mixture of liquid fuels. Further lab-scale quantitative testing is needed to refine the electrolyte recipe, the membrane composition, and other important design elements before larger-scale prototype systems can be constructed. The liquid metal energy storage system could be the key to unlocking the full potential of renewable energy. This is Paul Dufresne of Viridia Energia. Thank you for listening.